Hi, welcome to QBites, your bite-sized pieces of quantum computing. My name is Rene from Valorem Reply, and today we're going to hear much more about the fantastic Microsoft QDK, Q Sharp, and QIR. That's a lot, but Bettina will tell us all about it. And like I said, we have a special expert guest today, Bettina Heim, who actually works on all of those mentioned things directly and is actually one of the main drivers also behind Q Sharp. So we have a true Q Sharp expert here today. Hi, Bettina, and welcome to the show. Or should I rather say, Grüezi? You have to know she's originally from Switzerland. So, Grüezi, Bettina.
Yeah, hi Renee. It's great to be here. And indeed, I'm from Switzerland.
But yeah, so can you tell us a little bit about yourself and your background as it relates to programming, quantum computing, or quantum physics, or whatever it is?
Sure, yeah. So originally my background is in physics. I did my degree in physics, but then went on towards computational physics, modeling physical systems, and from there to optimization problems. So I like any kind of interesting, complex problems. So that brought me into quantum, and I fell in love with software engineering. I started working on Q Sharp, or before Q Sharp existed, and then building the compiler from there. And today I lead the compiler and runtime team at Microsoft Quantum.
That's impressive, and an impressive career. And if this is not impressive enough, I looked up and I found out that you were also a former competitive figure skater for Switzerland, which is just amazing. And I need to tell you something. Just recently, I had the pleasure to interview here also as QuBites Xenia Bogomolets, who was actually a professional contemporary dancer before she studied math and then became a quantum security expert, right? So it seems like there's a relationship between quantum computing, and dancing. Well, figure skating could be seen as dancing on ice, maybe, but there seems to be something related. Maybe it's just like the strength and
Yeah,
pulling through, because you need to have a lot of how should I say, strength, and of course, willingness to work through it, right?
yeah. I got to tell you, I'm also not the only former figure skater on our team. So apparently, if you are wondering how do I get into quantum computing and what should I learn, apparently the answer is figure skating.
Love it, love it. Okay, well, we got to talk about this another day, a little bit more in detail, but let's dive into today's main topic. In fact, I know you work on the Q Sharp compiler and other developer tooling, but those for the audience here that are not familiar with Q Sharp and QDK, can you please explain how Q Sharp and QDK are also related to Azure Quantum, and what Q Sharp and QDK are actually are?
Yeah, sure. So I know you're already familiar with Azure Quantum, and among other things, what you can do there is, of course, run things on actual quantum hardware. And Q Sharp is our dedicated quantum programming language. Quantum hardware works very differently than classical hardware. So having a custom language to make it easier for hardware to understand and make it natural for people to express the program is really important. And one of the coolest things about Q Sharp, I think, is that you can really do things that people didn't think were possible beforehand, right? Tight interaction between classical and quantum is something that now is starting to really come up, and hardware is starting to support it more and more extensively. And Q Sharp is kind of one step ahead of that, and we do a lot of magic to make that happen.
Nice. So it's a dedicated language for quantum computing, and also it's not dependent on a certain hardware stack, right? And this is really also where I think this QIR, the quantum intermediate representation, comes into play, right? And since um, like for the folks here in the audience that might be familiar with C Sharp and .NET, .NET has this CIL, the Common Intermediate Language, right? And so it's also this kind of layer between your actually programming language before you access the hardware, so that you're more flexible in terms of what kind of hardware you can support, right? Is that analogy actually also correct when we think about Q sharp and the QIR, the quantum intermediate representation? Or what is the purpose of the QIR piece here in Q sharp?
Yeah, definitely. On one hand, when it comes to intermediate representation, really what's important to us is what kind of information do we really need to ensure that everything executes, efficiently, quickly, to good quality, and all of that. And for us to really think hard about what's needed within the language and at the intermediate level is a very important step to make that happen. Like any intermediate representation, so usually the goal of formalizing essentially that format that basically the compiler internally uses is that multiple backends can connect to it and multiple languages on the front end can connect to it. But for us, mostly also what it enables is really that we have full control over how really to execute a certain programs. So we can make smart decision around which pieces go on quantum hardware, what pieces go on classical compute close by, what gets pre-evaluated ahead of time and all of these things, right? So that's the actual interesting compilation part that we do with that format.
Wow, I wasn't actually aware that this is also basically where it could, for example, split up. Okay, this is a piece for a classical computation, basically. This is not needed to run on a quantum computer, or actually wouldn't work. But you also basically represent it in QIR or can make these decisions there.
Right.
Wow,
Yeah.
that's
No, I mean, quantum hardware itself has no classical compute whatsoever. And then device manufacturers today, there are an arsenal of devices out there, and they often do have some classical compute really close by. So if you just use them,
yeah.
you might not realize what is running where. But of course, when you actually build the whole stack to work with that, you know exactly what goes where ultimately. And the interesting part is always when you measure it and you, for the first time, you start getting a classical value even, right? So this is kind of this connection between the two worlds. But anything beyond that, any variables or anything like that that you could have, that's not there on a quantum processor, right?
Yeah. That makes a lot of sense, and also, who knows what kind of, well, there is apparently already known what kind of different quantum computers are out there and will be coming, but we definitely don't know exactly which ones will be coming. So you get much more flexibility in the future, right? Because you can interpret your quantum algorithms even on newer hardware, as long as you have the correct backend support for QIR, right? Is that correct?
Yeah, exactly. And also we work with a lot of upcoming and kind of like experimental quote unquote hardware before it's already and in production to exactly
Yeah.
essentially develop the stack to support it and the hardware. So that's really what we hope to enable with QIR, which I'm really excited about. And it's also, I should mention explicitly, QIR is essentially just a convention for how to represent quantum programs within the LLVM IR, which is a well-established compiler framework in classical computing. So
Mhm.
we build on a lot of the existing tools for everything that we can, and then the actual quantum pieces, of course, require some dedicated attention and some customization that we do.
But it's super clever that you build on top of the open source LLVM, right? And that's it's fantastic because you can leverage some of that and also extend it. Super smart approach. Love it. And so, of course, QIR is more of a, well, not something as a developer you have to actually care so much about. Of course, you should always care about how things work under the hood.
Mhm.
But the question I'm going at is like, what as a developer you would probably use Q sharp, right? And then it does the
Mhm.
magic compiler, and all of that does the magic under the hood, so you don't need to care so much about it. That's the fantastic part about the compiler and the QIR, that you don't have to worry about all these specific things.
Mhm.
And but for developers who want to get started with Q sharp and the QDK, what is a good place to get started with for learning it?
Yeah, definitely. So it depends a little bit where your primary interest is, because you can do a lot in quantum computing. If you're interested in learning about quantum computing, quantum algorithms, how applications could look like, then we do have a great set of MS Learn modules and the quantum katas that I'm sure you've heard about before. They're a really great starting point to really engage just with the topic of quantum. But then there's also a lot of needs, of course, within quantum computing to write classical software for quantum computing potentially. And so here is where all the knowledge about, if you want to engage with a compiler framework comes in. We do definitely welcome that as well. Pretty much all of it is open source. So our GitHub repos are a good place to start engaging there.
Gotcha. Makes sense. Azure Quantum Learning and the GitHub repos, like you said, there's fantastic stuff. It's so much open source out there, and from the get go, it's great thinking. Hey, but maybe also this book is good to get started. And folks, I'm not getting paid to show this book. I paid for it myself, but it's just fantastic. It is Learn Quantum Computing with Python and Q Sharp by Sarah Kaiser, which were actually guests in previous episodes of QuBites, as well as her partner Chris Grenade. It's a fantastic book, and you know what? Bettina is actually also featured in there in the acknowledgement section. I quoted what is written there for working to make Q Sharp an amazing language, right? So, and I can definitely recommend this book if you want to get started. It's fantastic, and they consulted with the true Q Sharp experts, Bettina here. Well, Bettina, we could talk for hours and much, much longer, but we're already at the end of our short episodes. And so, thank you so much for your insights today and explaining all about Q Sharp, QIR, and the things you're working on. It's great work, and I think it's really amazing a groundwork that a lot of people will build on top of in the next couple of years. So, highly appreciate it that you joined us today and shared your knowledge.
Yeah, definitely. Thanks for having me here. And the credit, of course, goes always out to a whole bunch of people. There's a big team behind it. So, there are a lot of awesome people I work with.
Of course. Um, Thank you so much, everyone, also for joining us today for yet another episodes of QBites, your bite-sized piece of quantum computing. Watch our blog, follow our social media channels to hear all about the next episodes. And until then, take care and see you soon. Bye bye.